For these notes, we are going to be talking about distribution, which I have mentioned before also means the spread or the range of data. These words just mean how far apart the data is. So again, all of these words mean the same thing. We're going to be using the word distribution the most for these notes though. So there's three types of distributions: normal, skewed left, and skewed right. We'll start with normal distribution. The top one is a dot plot, and the bottom one is a histogram. You'll see that they're pretty much the same looking. If I were to take a bar and draw it over all the dots, it would look just like the histogram below. And then we've taken a line and we've curved it over the top of both of these graphs. And you'll see that they both have the same symmetrical type of curve for both the dot and the histogram. Normal distribution is the type of distribution we always want when we're looking at data. So for example, when I give my class a test, I'm always hoping that there's a normal distribution. There's a few numbers on the left and the right side of my graph, but the majority of my students are right in the middle, performing at about. This is the best kind of data that any statistician or teacher can hope for. So for normal distribution, data is evenly distributed or symmetrical. Symmetrical means if I were to take my pen and cut this graph in half, either one, they would be even on both sides. Or if I folded my paper over, we would see that this side of the graph would perfectly lay over this side of the graph. For these types of graph, the mean, otherwise known as average, is an appropriate choice for describing a typical value of the distribution because it represents the middle of the data. So the mean is always the best measure of center for normally distributed graphs. Now, graphs that are skewed, they can either be skewed left or right. And there can also be some that kind of don't really have any sort of skew, they're just all over the place, but we're not going to talk about those today. So when data is skewed, this is something I don't want to see when I give a test and I'm putting all my grades in the grade book. I don't want to see that a majority of students performed here, but then some students pulled in these super low grades. It means that I'm not teaching well, perhaps, or that students aren't doing what they're supposed to be doing, specifically these ones. It makes me wonder, these numbers appearing on the left-hand side, on the lower end of the spectrum. We also call these numbers outliers. Outliers are things that don't make sense with the majority of the data. So the majority of the data is here, and then we have these two outliers pulling our data down. You'll see down below that the dot plot is now represented as a histogram, and I've drawn a line over it. We call this end the tail, so it kind of looks like there's been a tail attached to the graph. When data is skewed, left in this case, it pulls the mean down. It's pulled our average down, and that's why I don't like having this happen in my grade book, because if we have outliers that are low, it pulls our, which isn't fair to the rest of the class, which is the majority, performing where they should. When the mean gets pulled down, the median stays the same and is now the better measure of center for the graph. So data is spread out longer, like a tail on the left. The median is higher than the mean, and the median is the appropriate choice for representing the center of data. That is because the median is not being affected by these outliers. Only the averages, or the mean. The median's not being affected because if I put all of these numbers in order, from lowest to highest, and then I ticked them in from left to right to find the middle would still be around here. The average is going to change because when I add these numbers up, but then add these numbers to that, and to pull my overall average down. Another way of knowing that this is left skewed is by putting your hand or your finger in the space. I know that this is a left skewed graph because my finger is on the left-hand side of the graph. This is an easy way of figuring out, is it left or is it right skewed? So always use the hand trick by putting your hand in the empty space. Right skewed data is exactly what it probably sounds like. It's the opposite of left. It just means that there are outliers now, the right or higher end of our numbers. This, a teacher's never going to complain about, because these numbers are going to pull our average or the mean back up. So it's okay if we have outliers that are outperforming the majority of our class. That's great. That's not a bad thing. We enjoy that. But it does, however, skew the average again. It's not the best measure of center. Again, the median is the best measure of center because it stays centered despite these numbers pulling our average up. Put your hand in the empty space. You'll see that your hand is in the right-hand side of the graph, thus making it right skewed. So again, data is spread out longer like a tail on the right. The median is lower than the mean, and the median is an appropriate choice for representing the center of the data.